Hello, friends. In our previous video, we have discussed one of the heuristic search algorithm, that is greedy best first search. Now, in this specific video, I'm going to discuss what A star search is. That is another informed search strategy that we follow. So, what basically A star search is, the idea behind A star search is it avoid expanding paths that are already expensive, as we haven't seen in case of greedy best first search. And what evaluation function that we are using, say in that in previous best first search example, that is greedy best first search example, we have discussed that the evaluation function fn that we are using, that was fsld, that is the basically the straight line distance from one node to another node, or from node to target. In this case, the evaluation function that we are going to use is gn plus hn. That means we are using the cost so far to reach n. That means the total cost reaching to the node n from one specific node, and the straight line, the estimated cost from n to goal. So both the cost will be evaluated in this case, and they will be estimated, and then accordingly fn will be calculated. That will be equal to estimated total cost of path through n to goal. In case of best first search, as we have already discussed, that it was only the hn, that is the estimated cost from n to goal, right? So here something is different, that is gn will be added with hn, right? So this is basically the example of A star search. We are taking the same example. We want to reach from Arad to Bucharest. So some person has started moving from Arad by following different cities that is being connected with that specific starting city, and the goal is to reach to Bucharest, right? So we have straight line distance that is being given over here, that is hn's value is being specified here, and gn value is basically the value that we are seeing over here. Okay, the total path cost of that one. So in case of Arad, as we are seeing, the distance is 366 that is being given over here, and its itself cost to the same city is 0. So it will be 366 plus 0, it is equals to 366. Now Arad is connected with further cities like Zerin, with Timisoara and CBU. So you are seeing, in case of CBU, we are getting 140, that is being the path cost from Arad to CBU, and then 253, that is the value of HN. So it is 393. The same for Timisoara, we have 447, and for Zerin we have 449. So in that case, the smallest value is 393. So this node will be selected for further expansion. From CBU, we are saying that different nodes are connected, like Oradea is there, Arad is there, Figueres is there, Remenkovilsia is there. So four specific cities are being connected with that one. If we are talking about the value of the Fn, that is Gn plus Hn, so in case of Arad, from CBU to Arad, you are saying 140 is this distance, but in that case, whenever we will see the gn value of that one, that is 366, so it is having some specific value like this. Same in case of Figueres, you are seeing from CBU to Figueres, so it will have some specific value, that is gn will be 239 plus hn, that is giving 176. So it will be added with that one, and you will get 415 over here. Same for Oradea, we will get 671, and for Remenkovilsia we will get 413. So according to all these distances, Remenkovilsia is having the minimum distance, that is 413. So this node will be selected for further expansion. After this, whenever we will expand Remenkovilsia, then we will see that there are different distances over here. So in that case, further, Pitatsi is having the minimum value that is being given 417, and then when Pitatsi will be selected for further expansion, Bucharest 418, that will have minimum value, and that is our goal node that is being selected in that case. So what we are saying, in case of the best first search, the path that we were selected was Arad to CBU, then to Figueres, and then to Bucharest. This path was selected in case of best first search, greedy best first search, we will say. But in case of A star search, what we are seeing, we are following Arad to Sibiu, then Riminkovilsia, then Petatsi, and then Bucharest. And we have discussed earlier that because of this way, it was not optimal because the total path cost that it is following is larger than the path cost that this A star search is giving to us. So in that case, we will say that A star search is optimal in comparison to best first search. If we are talking about the properties of A star, then we will say it is complete unless there are infinitely many nodes. So in that case, it might be possible that we will not get the complete result, but in general cases, we will say yes, the A star search algorithm is complete. In case of time or space complexity, it is similar to best first search, that is exponential time and space complexity is there, b to the power d. And if we are talking about optimality, as we have already discussed that yes, it is optimal, while greedy best first search was not optimal. And it is optimally efficient also. No algorithm with the same heuristic is guaranteed to expand fewer nodes. So in that case, yeah, it is optimally efficient also. So guys, this is enough for A star search. If you have any questions or queries, you can put it that in the comment section. And till then, please like and subscribe the video. Thank you very much.